Hello, student. Today we are starting our uh, following topics, and which is extinction of arc in circuit breaker. In last lecture, I uh, told you that the what is the cause and what is the reasons why arc is produced in circuit breaker, and why this arc is so important in the point of view of circuit breaker. So today we are see how we can extinction the this arc, and due to separation of current carrying contacts in a air of vacuum, an arc is formed. This arc exists for a short duration of time. Arc helps in a gradual transition from current carrying to voltage ionization state of contacts. Okay. But it is harmful on the account of large amount of heat generated due to arc. Hence, circuit breaker mechanism should extend the arc without causing any damage to the equipment or fatal accidents. Okay, so extension of DC arc is more difficult than the AC arc. Okay, so this is the one of the important point that you have to mark, that the uh, extension of DC arc is more difficult than the AC arc, because in AC system current becomes zero twice during one cycle. So if arc vanishes at this instant, it will not restrike again. So we have a chance in AC system that we can suppress this arc during this while our current is crossing the zero. Okay, so and we have a two chance that current, because current becomes zero twice during one cycle. Okay, but in DC we don't have anything like that. So extension of DC arc is a more difficult. Okay, so potential difference and amount of ionized particle between two contacts are the two major factors responsible to maintain the arc. Okay, so one way to extend the arc is to separate the contacts to such a large distance that potential difference is inadequate to maintain the arc, and increase distance between the contacts increase the arc resistance and further arc voltage drop. Okay, but this method is not practical solution for the high voltage switch case, where the real value of separation distance between contacts are in meters. Okay, so if we talking about the high voltage, then distance should be in meters, and we cannot develop such a big bulky capacitor. Okay, so in that particular situation, we have to think some other ideas that how we can extend this arc. Okay, so another way to extend the arc is to deionize the arc path by reducing the density of free electrons available between two contacts. This can be achieved by cooling the arc or by removing ionized particles from the space between two contacts. Okay, so now we will see the some methods of arc extension in circuit breaker. Okay, so usually two types of arc extension techniques are used in the circuit breaker, and first is high resistance interruption. Okay, high resistance interruption. In this method, arc is controlled by increasing the effective resistance with time, such a way that current reduced to value insufficient to maintain it. Okay, so what will we do in this particular scenario, that we increasing the effective resistance. Okay, so the rate at which resistance is increased should not induce harmful voltage in the system. Okay, so when arc extinct, most of the energy is dissipated inside the circuit breakers, and hence use of high resistance interruption techniques is restricted to DC circuit breaker and air brake circuit breakers of few hundreds MAV capacity is necessary. Okay, so resistance of arc can be increased by, so now we have a four method how we can increase the arc resistance. First method is the lengthening of arc. Okay, so the resistance of arc is directly proportional to its length, or we also have equation of resistance that and equation is the R is equal to rho L upon A. Okay, so if we increase the length, because length is directly proportional with the resistance, so if we increase the length, then ultimately it will increase the resistance of the arc. Okay, so the length of arc is increased by increasing the gap between the contacts. Okay, so this is first method of how we can increase the resistance of arc. Okay, second method is cooling of arc. Cooling of arc helps in recombination of ionized particles and removes the heat from the arc. Efficient cooling is obtained by a gas blast directed along the arc and reducing cross section of arc. Third method is reducing. So second method is, sorry, I forgot to explain that the cooling of arc, how we can cool the arc. Cooling of arc helps in a recombination of ionized particles and removes the heat from the arc. So we have to make such a arrangement in a circuit breaker that cools the arc. Okay, so efficient cooling is obtained by gas blast directed along the arc. Okay, so we will see how we can achieve this. uh, Third one is a reducing cross section of arc, because we already know that the resistance R is proportional, inversely proportional with the cross section area. So if we reduce the cross section area, then it will increase the resistance, and this it will be good for the us that we can quench the arc. Okay, so the cross section area of arc is reduced by letting arc pass through narrow opening, or designing a small area of context. Okay, so we can reduce the area by using this small area of context. Then fourth one is a splitting of arc. Okay, so how we can split the arc? The cross section area of arc is reduced by sorry, the resistance of arc is increased by splitting the arc into a number of smaller arc in series. Okay, so the arc is splitting up by introducing some conducting plates between the contacts. In other method, arc is forced into the arrangements of splitters. In each case, arc experiences the effect of lengthening and cooling. Okay, so these are some methods that we use to increase the resistance of arc. Okay, what we discussed, that the methods of arc extension. Okay, so first method is high resistance interruption, and the second method is a low resistance or a zero current interruption. Okay, so this method of arc extension is employed in a AC circuit breaker only because arc current becomes 100 times zero for 50 hertz AC system. This property of arc is exploit for the interruption, and afterwards the arc current will not allow to rise again. Okay, so this method will do that, they quench the arc and make a such environment that arc will not restrike again. Okay, so arc resistance is kept low until the arc current is zero, and when the arc extinguishes the naturally and is prevented from the restriking again. Okay, so the phenomena of arc extinction is very complicated and can be explained by two theories as follows. First theory is the recovery rate of Selfin's theory, and second one is, okay, is the okay. So second one is in second page. So we will discuss in later. First theory is the recovery rate or a Slepin's theory. The arc has enough voltage stress to dislodge the electrons from their atomic orbit at the time of dislodging the electrons, a large amount of heat is released. Okay, so this first line is very important. I am repeating this first line. uh, Arc has enough voltage stress to dislodge the electrons. Okay, so arc has a enough voltage stress to dislodge the electrons from their atomic orbit. Okay, so due to this arc, what will do, it will dislodge the electrons from the atomic orbit. At the time of dislodging the electrons, large amount of heat is released. Okay, so to prevent the further dislodging of electrons, it is necessary to remove the ionized particle or to produce a state of instability by recombining the electrons at faster rate than the rate at which they are dislodged. Okay, so we have to make such a system that it will recombine these electrons at a faster rate than the rate at which they are dislodged from their orbits. Okay, so if the rate at which electrons dislodge are faster than the rate at which they recombine, the arc will interrupt for the short time, but it will strike again. Okay, so uh, uh, we will be able to quench the arc once, but it will strike again due to the because the dislodging rate is faster. Okay, so this theory assumes that conduct of restriking a voltage and buildup of dielectric strength during recombination are independent quantities, and at some extent this assumption is not quite true because dielectric strength calculation do not agree with the observed value. Okay, so current falls to zero value twice during one cycle in AC system. At every zero current, arc extinguishes for the short time. Okay, so when medium between the contacts has a small dielectric strength, it breaks down due to the rising contact voltage and called the restriking voltage. If the such breakdown occurs, arc appears again and again. So arc restrikes and persists for another half cycle. So if immediately after current zero, dielectric strength of medium between the contacts built up faster than the voltage across the contact, arc does not appear again and current interrupts to zero. Okay, so we have to build a system that it will make dielectric, it will increase the dielectric strength of medium between the contacts after quenching the arc at the first current zero. Okay, so the fast increase of dielectric strength by sweeping the ionized particle away and replacing them by unionized particles are achieved by. Okay, so now we have some methods how we can increase the dielectric strength by sweeping the ionized particle away. Okay, so first method is lengthening the gap. Okay, so how dielectric strength or a post zero resistance depends on the length of the gap between the breaker contacts. Okay, so if we lengthening the gap by rapid opening of contacts helps to limit the arc energy and transient voltage due to the current chopping. Okay, so first method is to lengthen the gap. Okay, definitely we if we lengthening the gap, then it will increase the dielectric strength or it will increase the resistance. Okay, so second method is increasing pressure of medium. If pressure of medium between the contacts of circuit breaker increases, density of ionized particles creating discharge also increase. This increased density of particles further increase the rate of deionization and hence the dielectric strength. So if we increase the pressure, then it will increase the deionization rate. Okay. Third one is a cooling. Natural recombination of ionized particles take place more rapidly when they are cooled. Okay, so hence cooling for adjacent part of circuit breaker contacts by hydrogen helps to improve the dielectric strength. Okay, so and fourth is a blast effect. by blowing a jet of air between two contacts of circuit breaker, swaps away the ionized particle and replaces the unionized particles. We can say that they increase the dielectric strength considerably high. Okay, so this is how we can achieve the fast increase of dielectric strength by sweeping the ionized particle. Okay, so in next lecture we will go further in this topic. uh, we will discuss the another theory of how we can extend the arc. Okay, so up to now if you have any kind of doubt then you can comment it.